Flow measurements are essential to running a plant efficiently and safely. There is an array of flow measurement technologies available, including differential pressure flow, also known as DP flow, which utilizes a variety of measurement instruments. DP flow is measured with a combination of a primary element and a secondary element. A primary element is placed in the pipe to create a differential pressure while connecting the secondary element to the process. The secondary element, or transmitter, takes measurements from the primary element and converts them into useful quantitative values and transmits those values to a control system. There are many types of primary elements, including traditional orifice plate, cone, venturi, nozzle, wedge, Rosemount Annubar averaging pitot tube, and Rosemount conditioning orifice plate. Primary element selection is dependent on process conditions. All of these different primary elements have one thing in common. They constrict the flow in a pipe, causing a pressure drop from one side to the other. The difference in pressures is the differential pressure. The square root of dP is proportional to the flow rate. Traditionally, transmitters were connected to the process with external impulse piping. Impulse piping is a major expense and gives opportunities for multiple leaks and creates unnecessary safety hazards by adding extra valves and manifolds to the process connection. Now, with new and improved primary elements, the impulse piping is built into the primary element. This allows the transmitter to be directly mounted to the isolate and equalize valves, resulting in an integrated flow meter. The built-in piping is factory leak checked, makes installation easier, and reduces maintenance costs. The impulse piping of the integrated flow meter runs from the process through the primary element to the sensing diaphragm of the transmitter. On one side of the transmitter is the high pressure side, on the other, the low pressure side. The diaphragm deflects relative to the pressure change from one side to the other. It is very sensitive and can detect very small changes in pressure. The transmitter then relays the dP measurement to the control system. Today's advanced multi-variable transmitters perform a compensated mass flow calculation in the transmitter of the integrated flow meter. The multi-variable transmitter measures static pressure, differential pressure, and process temperature in one device. DP flow is the most popular flow technology throughout industry due to its simple design and flexibility. DP flow is well understood, and many international organizations have standards written around it, including ISO, AGA, and ASME. DP flow meters are easy to install, troubleshoot, and calibrate.